So in this video, I want to continue a problem. We just found the derivative of the function f of x. By using the definition, we got that it was f prime was equal to 2x. Now I want to find the slope of the line tangent to the graph of f of x at the point 3, 14. So how do I do this? Well, the first thing I do is I take my slope machine, all right, and I look at the value x equal to 3. That's my input 3 there. I'm going to look at that value, and I'm going to plug in 3 into my slope machine. And what's going to happen is I'm going to get 2 times 3, and that gets me 6. And that's all there is to it. Therefore, the slope is 6 at the point 3, 14. How easy is that? Okay, so now we're going to extend this beyond finding the slope of a tangent line at a particular point, and we're going to find not only just the slope of that tangent line, but we are now going to find the equation of the tangent line. Okay, and so I want to find the equation of the tangent line. It's tangent to the graph at the point 3, 14. And then after I do that, I want to graph it. So what we need to do this is we need a point and we need a slope. Guess what? This is from college algebra. Y minus y1 equals m times x minus x1. If you want to go into my college algebra videos and see how that formula is derived from an arbitrary point, x1 comma y1 and x2, and then slope m, be my guest. Okay, so you can do that if you want to. So this is based off some slope m and some point x1 comma y1. Okay, that's where that's coming from right there. It's a point slope formula. Now, what do we need to figure this out? We need the slope and we need the point, the two things that are in the formula. So the slope is equal to the derivative evaluated at the point. So what do we know? The point is x equal to 3, y equal to 14. So I plug in 3 for my value. Well, I've already done this work. I get 6. And then my x1, y1 point is my 3, 14. So I'm literally going to take my y value, my y1 value, and replace it with 14. And I'm going to take my x1 value and I'm going to replace it with 3. And then my slope, m, is equal to 6. So I'm going to take those values and I'm going to plug them into my formula. And so now all I have to do is solve for y. And if I solve for y, what is that going to get me? That's going to get me 6x minus 3 in parentheses there plus 14. Now if you want to, you can multiply this out and get 6x minus 18 plus 14. And so that's 6x minus 4. Perfectly fine to do that. If you want to leave it in the form, this form right here, that's perfectly fine. Unless I tell you to put it in slope-intercept form, or, remember slope-intercept form is y equal mx plus b, right? And once again, that's in college algebra 2. You can look at those videos if you're having trouble remembering those formulas. So this is perfectly fine right here if you want to solve for y and simplify. Perfectly fine by me. Okay? Now, let's graph the equation of f of x. Remember, f of x is the parabola x squared plus 5. So I'm going to take x squared plus 5. So I'm counting each block is by 2's, okay? So I've got x squared plus 5 graphed here. Now, I want to know the slope of the tangent line at the point 3, 15. So if I go over here, okay, so 3, 14 is this point right in here. I'm not perfect, but close enough. Okay. I'm sorry, right in here. So 3 comma 14 there. So that's what that point is right there. And if I graph the equation of the line right here, 6x minus 4, then I see that it lines up just perfectly. Okay? So this is the graph of the tangent line at the point 3 comma 14. Okay? Now, there's a way to do this in general. And so in general, to find the equation of the tangent line, it amounts to, so I'm going to use t for tangent line. So the equation of the tangent line is equal to the slope evaluated at the value c multiplied by x, which is arbitrary, minus your value c, and then plus your y value there, which is f at c. Okay? So you think about it, this value in general is c comma f of c, okay? And the slope m is equal to the derivative at the value c. So that's where this slope m comes from, x minus the x value plus the y value here, the y1, and then this is the x1 here, and that is my f of c that's going in right there, okay? So you're literally solving that equation, x minus x1 plus y1. That's where that formula is derived from, okay? So this is the tangent to the graph of f of x at x equal to c. So that would be like if this was x equal to c value here, okay? For this particular case, c is what? C is equal to 3. That was the point at which we had our x value where we plugged in, okay? That c there was equal to 3 for this particular one here. So if you use the formula here, you'd have f prime of 3 times x minus 3 plus f of 3, okay? So what I'm looking for, I want to see the work to get f prime. I want to see the work to evaluate it, and then I want to see you plug it in and then find the y value that associates with that. That's where that f of 3 comes from, okay? Just like that. And so my tangent line, t of x, the equation is written for you right there. Okay, guys. Hopefully that helps you out. In the next video, we'll talk about something that's kind of the opposite of the tangent.